Okay, same idea here. Let's go ahead and try and factor this, but notice we have sine squared and cosine x, so we're going to need to use a Pythagorean identity to rewrite sine squared. So I know that sine squared of theta equals 1 minus cosine squared of theta. That's the Pythag identity with a cosine subtracted from both sides, cosine squared subtracted from both sides. So I can say that negative 2 instead of sine squared x, I can say 1 minus cosine squared x plus 3 cosine x plus 3 equals 0. And that might look messier to you, and it is for the time being, but let's distribute that negative 2 to get negative 2 plus 2 cosine squared x plus 3 cosine x plus 3 equals 0. And notice I'm going to combine that negative 2 with this 3 to get a positive 1 right there. And then I'm going to say let I don't know, how about w equal cosine of x, because then I can say 2w squared plus 3w plus 1 equals 0. Again, I make a substitution to make it look easier to work with. And so I end up with this quadratic that I can, again, factor. So let's factor it as a 2w plus or minus something times a w plus or minus something equals 0. And what does that something need to be? Well, the something needs to add to positive 1. I goofed it up again when I said it needs to multiply to positive 1, so we need a 1 and a 1 there. And they're both positive, so they need to be positive right there because of that positive 3w. Check it. 2w times 1 is 2w, and 1 times w is w. 2w plus w is 3w. So we're good. So what are the solutions then? Well, the solutions are going to be w right here is going to need to equal negative 1/2, and here w is going to need to equal negative 1. But again, we know that w equals cosine of x, so we can say cosine of x equals negative 1/2, and cosine of x equals negative 1, because it's the same as w. All right, well, when does that happen? Draw yourself a circle. When is cosine negative 1/2? Well, that's going to happen right here at 2 pi over 3, and it's also going to happen right here at 4 pi over 3. And then when is cosine equal to negative 1? Well, that's going to happen right here at pi. So those are my solutions, but again, I need to express them as some multiple of a full cycle, 2 pi, plus that solution. So we need to say that one set of solutions is going to be x equals 2 pi over 3 plus 2 pi n, again, for all n in the set of integers. Next solution, x is also equal to pi plus 2 pi n for all n in the set of integers. And finally, x is equal to 4 pi over 3 plus 2 pi n for all n in the set of integers. There you have it. Those are my 3 sets of infinite solutions.